This is 11.4, number 6 in your e-text. Algebra 2, Martin Gay, 2016 edition. The problem type is a rational function with a monomial containing a variable in the numerator. So the simplest case is when the numerator was a constant, but in this case, we actually have a variable. When the numerator was a constant, when calculating the x-intercept, remember the pattern. What happens is we get a false statement or a contradiction, and therefore no x-intercepts exist. Based off the form of the problem, what do you think happens to the x-intercepts this time? You're probably used to it and you may already know the answer. Every time there's a monomial in the numerator with a variable, the x-intercept will be 0. Let's see. First off, the horizontal asymptote would be y equals the ratio of the leading coefficients, 4 divided by 1, or 4, since the degree of the numerator equals the degree of the denominator. Vertical asymptotes set the denominator equal to 0. Of course, as I always say, you could probably do this in your head, but just show some work. X squared equals 9. Square root both sides, you get plus or minus 3. As we were saying, x-intercept, set y equal to 0. We get 4x squared over the denominator. Again, you could probably predict what's going to happen. You multiply both sides by the denominator, so you get 0 equals 4x squared. Again, in the previous problems, there's no variable here. So you'd get 0 equals 4, which would be a contradiction. So in this case, we do have an x to solve for. X squared would be 0 over 4, which is 0. So the x-intercept is 0 instead of none. Y-intercept, y equals 0, because we plug in 0 for x. 0 over anything, 0 over -9 is 0. Next step, we list all the vertical asymptotes, all the x values, and the x-intercept. And then we're going to plug in all numbers besides the -3, the 0, and the 3. So a -1, +1, and a 4. So we get f of -4 gives us 4 times -4 squared, all divided by -4 squared minus 9, which is 64. The bottom is 16 minus 9, or 7. 64 over 7 is about 9.14. Next, we do f of -1. This is 4 times -1 squared, all over -1 squared minus 9. This gives 4 over -8. -0.5. Perfect. Next, we know f of positive 1 should look just the same. That's going to give us a negative 1/2 again. And likewise, f of positive 4 is going to give us 9.14 again. Plot all these points. So I plot my vertical asymptotes at -3 and +3. My horizontal asymptote was, let's see, it was equal to 4. So I'll just write that slightly above 3. And then we have -4 on the x, 9 on the y, 4, 9. Oh yes, and the x-intercepts were 0, 0, and the y-intercept. Then we had -1 on the x, -1/2 on the y, 1 on the x, -1/2 on the y. So just slightly below. Connect the points and curve towards the asymptotes. And then below is the shape of my parabola. And that's how you plot the graph of a rational function where the numerator is a monomial containing x.